All right, lesson 17.2 is about outdoor air quality. So we're talking about how the ambient air, that's what we call the air outside, and the issues currently facing it. So there are a lot of pollutants, and air pollutants are gases and particulate material added to the atmosphere that can affect climate or harm people and other living things. So if those are the definitions of if that's the definition of air pollutants, air pollution is the release of those pollutants from mostly from human activities. And so in recent decades, public policy and improved technology has helped reduce most types of outdoor air pollution in industrialized nations. So actually addressing air pollution is one of the best successes that humans have had in addressing environmental problems that we have mostly caused. It's still very much a problem in industrializing nations and in urban areas. LA comes up continually in this section because we have very bad air quality. And 3.3 million people die prematurely each year because of health problems from air pollution. And these air pollutants can also act as greenhouse gases, which can contribute to global climate change. So there's a lot of factors going on here. So some pollution is from natural sources. So natural processes, which can be worsened by human activities, can also pollute the air. So it's not only smokestacks blowing smoke into the air, but also just things that happen naturally on our planet. So for example, fires occur naturally, but are worsened by human encroachment into fire-prone ecosystems and the suppression of fires in area where it is part of the natural ecology. So we've talked about this, how fires are a natural part of the ecosystem cycles, but we have made them worse because of suppression, and they are worse as humans move into the fire-prone ecosystems and do things like leave burning cigarettes around. So we have made the pollution from fires worse, but fires are natural and they do pollute the air as they release soot into the air. Then we also have volcanic eruptions that release particulate matter and sulfur dioxide into the stratosphere. So really quickly, let's differentiate between particulate matter and gases. Gases are compounds or elements that are in their gaseous form. Back to chemistry, we have solid, liquid, and gas. So they are a gas. Particulate matter are really, really, really tiny pieces of solid, whatever it might be, but they're so small that they like float in the air. So that would be more like soot. Then that's not a gas, it's a solid. So short-term effects of volcanoes include grounding planes, damaging car engines, and causing respiratory illness. And long-term effects such as global cooling can occur if sulfur dioxide reacts with water and oxygen to form aerosols that block sunlight in the stratosphere. So there was a eruption at some, I don't have it written down, but that actually cooled the whole planet by like 5 degrees one year because it blocked so much sunlight from getting down to below it. In 2012, a volcano called Popocatépetl, whatever it is, it erupted right outside of Mexico City, which added to the region's pollution challenges. So there are volcanoes erupting and they are causing negative effects to the air around it. Wind is also a natural occurring source of pollution. So wind sweeping over arid terrain, meaning dry and warm, can send huge amounts of dust aloft. So winds can sweep up dust into the air that would be particulate matter. This is worsened by unsustainable farming and grazing practices that strip vegetation from the soil, as well as desertification. So this is taking us back a few chapters. So humans are making it worse as we practice unsustainable farming. So we are killing the land and depleting the soil, leading to desertification. So this is actually dust blowing from Africa across the Atlantic Ocean to the Americas. So those are the natural ways. Fires, volcanoes, and wind are some of them, but we also create lots of outdoor air pollution. And there's two kinds of pollutants. There's primary pollutants and secondary pollutants. Primary pollutants that are pollutants that come straight from a source, and those are called primary pollutants. So ash from a volcano, sulfur dioxide from a power plant, or carbon monoxide from a car are all examples of primary pollution, primary pollutants. Secondary pollutants occur when primary pollutants have been released and they react with each other and components of the atmosphere to form secondary pollutants. So ozone is a positive thing, which we learned about. It's positive if it's in the troposphere. I'm sorry, it's positive if it's in the stratosphere, but it's not good. It's a pollutant if it's in the troposphere, and that is because it's formed from pollutants in urban smog. So that's a secondary pollutant. Ozone isn't released from anywhere, but it reacts with stuff in the atmosphere to get made. These pollutants can also be point source or non-point source, same as aquatic pollutants. Point source would be like a coal-fired power plant is going to be releasing a lot of sulfur dioxide and soot and all of those things into the air, whereas non-point source would be the millions of automobiles. I mean, each one of them is releasing pollution, but as a whole, that would be non-point source because it's more diffuse and it's consisting of many small, widely spread sources. So a characteristic of a pollutant is called, or one of them is a residence time, which is the amount of time a pollutant will spend in the atmosphere before it settles on the ground. A short residence time results in more localized impacts over short periods, so they're only going to stay in the air for a short period of time, whereas long residence times will cause global, long-term, regional, or global effects. So most particulate matter and most pollutants from automobile exhaust only stay aloft for hours or days, which is why air quality in really big cities such as Mexico City or Los Angeles can vary from day to day because the pollutants that are the worst there have a short residence time. But the pollutants that, some pollutants that have long residence times are things that lead to climate change and deplete the ozone layer, which are two separate things. Climate change and the ozone layer are not related. Or global warming and the ozone layer are not related. So if we look at this graph, centuries are things like CFCs, which affect the ozone layer, carbon dioxide, methane, dinitrogen oxide, all of these things, they are going to last for centuries, and that is why it's such a big problem. Then we creep down. Carbon monoxide, that's what this is. It can take months to years, which is not great at all, but still better than centuries. And so it can affect like half the planet. These will affect the whole entire planet because they will last forever. Then we have tropospheric ozone, which remember is ozone that's in the troposphere, so our layer of the atmosphere instead of the next one up, the stratosphere, where it belongs. Then there's things like sulfates, nitrates, ammonia, and particulate matter, the PM 2.5. And then the locals are things like nitrates, ammonium, and other particulate matter, which will settle much more quickly. So we have what's called the Clean Air Act. So it was passed in 1963, amended in 1970 and 1990, and it funds pollution control research, set standards for air quality, and encourage emission standards for automobile and other point sources. And it imposes limits on emissions from new sources, funds a nationwide air quality monitoring system, and enables citizens to sue parties that are violating the standards. So you or I could sue someone if they thought we were violating the Clean Air Act. And under the Clean Air Act, the Environmental Protection Agency, the EPA, set nationwide standards for emissions of several key pollutants. So they set levels that are allowed for to be emitted of certain pollutants, and also standards for concentrations of major pollutants in ambient air. Remember, ambient air is the air that's outside. And so states are required to monitor emissions for air quality and develop, implement, and enforce their own regulations to comply with the law. So these agencies that monitor these emissions, there can be state or local, and they report the EPA the amount of 6 major pollutants. So the first one is carbon monoxide. So carbon monoxide makes up 62% of the pollution. It's a colorless, odorless gas produced by the incomplete combustion of fuel. So it is released anytime there's fuel being burned, most notably from cars. Vehicles and engines are the biggest source. Carbon monoxide binds, and the reason why it's so dangerous is because, well, it's colorless and odorless, so you won't know it's there, and it binds to the hemoglobin in red blood cells, which is the protein that's found in your red blood cells that attaches to oxygen. And so since the carbon monoxide binds to it, regular oxygen can't, and then your blood is no longer carrying oxygen to your cells, which is very bad. It can also be created from industrial processes, waste combustion, and residential wood burning because it's the incomplete burning of the incomplete combustion reaction. And so in this process where it binds to your hemoglobin, it can cause nausea, headaches, fatigue, heart and nervous system damage, and potentially death. And so this is why you never pull your car into a garage and close the garage door and leave the car on because the garage will fill up with carbon monoxide. You also probably have a carbon monoxide alarm everywhere in your house to test for it because it is so dangerous and so hard to detect otherwise. Then we have sulfur dioxide. So sulfur dioxide is this little green sliver right there. It's a colorless gas with a pungent odor, and it comes from the combustion of coal for electricity generation and industry. I don't think that's on your slides. I'm not sure why it wasn't there, so I added it. And during combustion, so the burning of coal, sulfur, which is found in the coal, reacts with oxygen to form sulfur dioxide. And once this is in the atmosphere, it will react to form other things, sulfuric acid and sulfur trioxide, and that will lead to acid deposition, aka acid rain. So that's why that one is so bad. Then we have nitrogen oxides, which are these guys, the purple guys. They are produced they're a family of compounds that include nitric oxide and nitrogen dioxide. So this X means that there could be given many different numbers there. This is produced when atmospheric nitrogen and oxygen combine during combustion in engines. Notice there's a pattern here that these are all happening during combustion, either of burning fossil fuels like coal in a factory or burning fossil fuels in a car. And the NO emissions contribute to smog, acid deposition, and ozone depletion. Then we have these things called volatile organic compounds, VOCs. This is the dark orange one here. They are carbon-containing chemicals emitted by vehicle engines and solvents. And examples will include methane, propane, and octane, all things that we use for fuel to burn. And the VOCs will react to produce secondary pollutants such as smog. Then we have particulate matter. This is what we talked about before. It's solid or liquid particles small enough to be suspended in the air. So this can be a primary pollutant such as dust or soot, which comes off from a combustion reaction, or a secondary pollutant like sulfates and nitrates, which occur when other compounds react in the air with oxygen. So particulate matter is classified by size. So PM10 particles are less than 10 microns in diameter, and PM 2.5 particles are less than 2.5 microns in diameter. So these ones are much smaller. That's why if we come all the way back here, the PM 2.5 lasts for longer because they're lighter. These ones are heavier, so they'll fall faster to the ground and get out of the atmosphere, but the PM 2.5s will hang out for a long time. And these smaller particles are more likely to get deep into your lungs and cause respiratory disease and heart problems, so not very good. Then we have lead, whose atomic symbol is Pb. It's a heavy metal that can enter the atmosphere as a particulate pollutant as a result of vehicles burning leaded gasoline or metal smelting. Smelting is the process of getting metal out of a metal ore. We don't really need to know much more about that process, but as long as you know that lead can be released into the atmosphere through lead smelting. Lead is a toxin that can accumulate in the body and cause nervous system malfunction. Unfortunately, we didn't know that a long time ago, and lead was in paint, it was in gasoline, it was around all the time, and now we know it's really dangerous. So it was mostly phased out in the 1980s from gasoline. It enhanced engine performance, but we took it out when we realized it was bad. That's why gas these days is called unleaded. So metal smelting is still the main source. So those are the six main pollutants that are human caused. But we have actually really reduced pollutant emissions since 1970 when the Clean Air Act was passed. They've reduced dramatically. And this has occurred despite increases in population, energy consumption, miles traveled by vehicle, and gross domestic product, because so even though all those things are increasing, we have been able to just make cleaner cars and cleaner engines and things like that. We control pollution as a result of policy and technical advances, which have been motivated by grassroots social demand for cleaner air. So people are demanding that we get cleaner air. So companies have started to change. That's why we have things like hybrids. We have things like cleaner burning engines, cleaner burning fuels, all of those sorts of things.